Unit 8, Lesson 4, and this is the second instructional video. And throughout these next 6 examples, they are going to line to 7 through 12 from the homework. Let's start with example number 7. Find the half-life of a radioactive substance if after 50 days 4 grams remain from an initial sample of 9 grams. This is the formula we will use throughout the next 6 examples. So N of T represents the remaining quantity, N of O is the initial amount, half-life raised to the, this is how much time has elapsed, and this is for any particular substance they have their own half-life. So we're going to rely on this. Let's look at what we have. Find the half-life of the radioactive substance if after 50 days. After 50 days, that's the time that's elapsed. After 50 grams, 4 grams remain. So that's the remaining quantity. We want to find out the initial grams, 4 grams remain from the initial grams of 9. So this is the initial amount that we have. And we want to know what is the half-life. We don't know this amount here. I'm going to put an X. Again, time elapsed, 50 days have elapsed. We're talking about a half-life. This is the X one on the 1/2. 4 grams remain of the substance, and we started with 9 grams. So how do we go about solving for X in this instance? Well, the first thing I'm going to do is we're going to divide by the number in front of the 1/2. So I'm going to divide both sides by 9. So I have 4/9 equal 1/2 raised to the 50 divided by X. Now, just like when we worked with examples 1 through 6, we were working with a base of E, and we took the ln, which is log base E. Now I'm going to take the log base of 1/2. Log base of 1/2. And in doing so, log base 1/2 and 1/2 will be eliminated because they will simplify to 1, and I'm left with 50 over X equals log base of 1/2 of 4/9. Now, how do we go about solving this? Well, think of this quantity over 1. So right now I can cross multiply. I can take X times this quantity, and for the purpose of me not writing this twice, I'm just going to make this into a hash mark. So I have hash mark times X equals 50 times 1. So 50 equals hash mark times X, divide by that hash mark, and you're like, what is a hash mark? That's this quantity right here. So X equals 50 divided by log of 1/2 of 4/9. So how do we plug this in? And what is this? What does it equate to? Remember, every substance has a different half-life of 1. So a half-life, for instance, if we had a substance that started with 100, and then if the half-life was 1 day, that means the next day it'd go from 100 to 50, right? And then it'd go from 50 to 25 the next day. And every day, if the half-life was just 1 day, right, it would divide by 2 if the half-life was 1 day. Okay, so how do we plug this in? I'm going to take 50 and I'm going to divide it by, now how do I get to this? You're going to hit math and you're going to go up 3 times, and we can type in 1/2 or 0.5, whatever you choose, and then 4/9. And there we go. So I have 1, 2 in front. That looks great. I'm going to press enter. And so I have the half-life is approximately 42.7. Now we can compare days. We can look at the units. We can see that the half-life is in terms of days here. So 42.7 days. At this time, please go ahead, press pause in this video, and I want you to complete problem 7 from the homework. All right, we're looking right now at example number 8. And so determine the amount of radioactive substance remaining. Remember, this is the initial, this is the remaining amount, this is how much time has elapsed, and this is the half-life of a substance. So we want to know how much is remaining. This is what I want to know. I want to know this area after 120 days has elapsed. So this is the 120 days has elapsed. We have a half-life of 30 days. I'm just going to point where we have it, right? And then the initial amount right here, when t equals 0, that always represents initial, is 40. So I'm going to replace this part with an X. I want to figure out how much substance remains. I know the initial amount is 40 grams. I know that 120 days has elapsed, and the half-life of this substance is 30 days. So every 30 days, it would go ahead and be divided by 2. So how do we solve here for X? I'm going to first worry about this part. So I'm taking 1/2 in parentheses, and I'm raising it to, in parentheses, anytime we have a fraction, 120 divided by 30. That's this portion, and then I'm taking it times 40. So we can say it would be approximately 2.5, let's look up above, 2.5 grams would be remaining after 120 days. Please go ahead and complete problem number 8 from the home. Looking at example number 9. Again, this is something that's new to some students. So this is the remaining amount, the initial amount. We're working at the half-life right now. This is time that it has elapsed, and this is the half-life of a particular substance. After 120 days, so that's how much time has elapsed, right? After 120 days, 8 grams remain, okay? That is your remaining substance. The half-life is 7, and we want to determine this initial amount. So this is what we want to determine. So I can replace n of t with 8, that's the remaining amount. I don't know the initial amount. I know that 20 days has elapsed, and the half-life is 7. So I want to figure out x is attached to this quantity. And so opposite of being attached or multiplying is dividing. I'm going to say this is equal to whatever. It's equal to whatever this amount is. I need to divide both sides by that amount, and then I'll be able to come up with this. So I'm going to take 8 divided by whatever this quantity is. So 8 divided by, now in parentheses, 1/2 raised to, you know what, I want to make sure I plug this in right. First I'm going to take 1/2 raised to the 20 divided by 7. That's this quantity. Now, I want to take 8 and divide by that. I can copy and paste this in by hitting the blue key and the key right below the 3 that says answer. So the initial substance is approximately 57.97 grams. Okay, at this time, please press pause and go back to your homework, completing problem number 9 and checking for accuracy. Look now at example number 10. A 4.1 gram sample of substance is known to be 325 years old is found. What is the original mass of the substance? Okay, so I want to know the original mass. This is what I want to know. What is that initial or original mass? I don't know that. We know the half-life, so we know the half-life. The half-life is 4,320 years. It's found, so time that's elapsed is 320, and when it's found, at this point, there's remaining is 4.1 grams. Remaining, that's when it's found. It's found after this amount of time has elapsed. This is the half-life, and now we're going to do the exact same thing that we did for the previous example. I know that 1/2 raised to this amount is going to give me some value, but it's stuck with x. Opposite of being stuck is dividing by. Stuck is multiplying. So whatever that amount is, I want to divide both sides by it. And then I can figure out what is x equal to. So just like I did last time, let's first figure this out. Putting it in parentheses is key. Okay, so that's this amount. I want to take 4.1 and I want to divide by that exact amount. So I'm going to copy and paste that in. And we can see approximately 7.01 grams would be the initial amount. Please go ahead and complete problem number 10 before coming back. Alright, 7-gram sample of substance thought to be 400 years old is discovered. Okay, so this is the time that's elapsed. The original mass of the sample is 10 grams, so that's the original right here, the initial. Determine the half-life. We don't know what this is. Okay. A 7-gram sample of substance is thought to be, okay, so this is what is remaining after this many years. So remaining is going to go, always going to be the n of t. We know the initial amount was 10. We know time that's elapsed to get this amount is 400 years, and we want to know what is the half-life, determine the half-life. Slightly different than our previous 2 examples, slightly different. And so what we're going to do right now is we're going to go ahead and let's first divide by 10. So 7/10 equals 1/2 raised to the 400 divided by x. Now, in examples 1 through 6, when this was an e, we took the ln, or log base e, of both sides. Now, to remove the 1/2, we're going to take log of 1/2, log of 1/2. On the left and right hand side, we can continue to Go ahead here, log of 1/2 to the 7/10 equals 400 divided by x. And I know that this quantity, I can put a 1 underneath it. So let's go ahead and let's cross multiply. So x times whatever this is. And I'm going to be lazier and say this amount is equal to this hashtag. And so x times hashtag equals 400 times 1. So 400 equals hashtag times x. Now, really, what is hashtag? It's this amount. So over here, I'm going to write this down. It's log of 1/2 of 7/10. That's what x is going to equal. So I'm first going to figure this out and then take 400 divided by it. So how do I get to log of 1/2? I'm going to hit math and go up 2 places, or 3 places. And whether you plug in 1/2 or 0.5, you'll achieve the same answer of 7/10. Press enter, and I want to take 400 and divide by this exact amount. We can copy and paste it in by hitting seconds and answer. And so we can see that the half-life would be approximately 777.3 years. All right, go ahead for me, please, and complete. I think you're on to problem number 11 from the homework before coming back. All right, our last example here. A substance with a half-life of 1,740 years has an initial mass of 11. How much will remain? So we're always going to start by writing this formula when we talk about half-life. Okay, a substance with a half-life. So we know this is the half-life. Has an initial amount of 11. And how much will remain after? So this is the elapsed time, and we want to know how much will remain. This is our remaining amount. I'm going to put in as x. When I plug this in, I'm going to do this amount first, and then I'll take it times 11. So 1/2 raised to the. Anytime we have a fraction, we're going to put it inside parentheses, and then let's take it times 11. So remaining will be approximately 7.39 grams of substance. Okay, go ahead and complete problem number 12 in the homework next.